1, 2. So guys, please take your seats. Okay. So hi everyone. I'd like to welcome you on the next Cloud Native Prague Meetup. Before we start, just some information that you can take the beer. You have to just turn left, and then there's the kitchen where you can tap the beer. And also, if you wanted to go to the toilet, so just turn right, and then turn left for men's and left and right for girls. So that's it. And also, you can see some merch on the table, so feel free to take it. I don't want you to take it at home. So today, the theme is the Kubernetes configuration management. Something about me. I work as the ambassador for the Cloud Native Computing Foundation. It's free of charge job, so don't quit job, please. What is CNCF? So maybe you know it, that the CNCF is just a foundation which helps the open source project to grow. So if you if you wanted to get some new contributors, so feel free to join the CNCF projects style, like the incubators and stuff and other projects. And also they can provide you some resources for your SaaS solutions. So maybe you know some projects like Kubernetes, Prometheus, OpenTelemetry, and stuff like that. There's more than, I think, 150 projects right now. So yeah, almost everything which you are using in the cloud. Something about our community. So if you wanted to get the notification for our upcoming events, so please just join the cloudnative prague.cz. It's our Ivan? Technical issues, so give us some time.
It's a pleasure to welcome you in Etnetera Core Prague. My name is and I've been working with Etnetera since 2012. Well, 20, sorry, it will be 3 years already. And I'm a DevOps engineer and with the background of Linux administration. And when I come to Etnetera, our first project was the first project running Kubernetes. So we had to decide what will be used to deploy our application to Kubernetes. And after some struggles, we decided for Kustomize. So I will be talking about it today. So first, we will just scratch the surface to know how the Kubernetes works and how do you communicate with it. To communicate with Kubernetes, you need Kubernetes API, and that's everything that you want to do with the cluster must be done through the Kubernetes API. And there is the kubectl tool, which is like the foundation tool that is used. But also, of course, you can use whatever tool you want to communicate with the REST API. And the REST API specification of Kubernetes includes put and patch methods, and also dry run, which is cool that you can run your requests against the Kubernetes, and you can just check what would happen if you run it. In the REST specification, the put method is used to create the resource if it is not existent, and to update it if it already exists in the Kubernetes. And it means that it's declarative, and it should be idempotent if you run the put method like several times, and it should just create the resource there. And the patch method, it works with a partial payload that you don't have to create the whole resource again, and you just send a part of the data, and the existing resource in the Kubernetes should update. So if you need to run something in Kubernetes, you have to write your manifests according to the specification. And for that, to apply it to the cluster, you use the kubectl apply or other commands of kubectl. So the apply, it is counterpart of the put method. So it will create the resource if it is not there, and if it will update it if it is already existent. There are some fields of the manifest that can't be updated when it is already there. So if you need to make a change, you can always use the replace command, which will delete and then recreate the resource in the Kubernetes. There's also a patch command, which again uses the patch method to apply like partial update using a strategic merge, JSON merge, or JSON patch. So it is built inside the Kubernetes API. The strategic merge requires a merge strategy which must be defined in the API reference of Kubernetes itself. You totally don't want to keep all your manifests on, I don't know, on disks and to deploy them like directly from the Okay, so if you hear me now, it should be better. So I will continue. So you want to deploy your applications to the cluster, and you would like to change it a little bit for each environment there. For that, you need some Kubernetes configuration management system. And the most known, I suppose, is Helm. So I would like to ask you if anybody is using actively Helm. Okay, like a third, maybe more. Who use Kustomize? Okay. And is there anybody who uses JSONnet? Okay, also a few people. And there are another management systems like KPT. You can create your manifest using Ansible, Terraform. There is the whole like ecosystem, or how to say it, for the infrastructure as a code called Plume, and there are a bunch of other management systems. But Kustomize, it's a native part of kubectl, but you can download it also as a standalone binary. As I already mentioned, a lot of API capabilities are used directly in Kustomize. So in Kustomize, you use approach where you like rebase or patch, like in software packaging. So for example, in my experience, when we developed some embedded systems, we took a vanilla Linux kernel and then we wrote some changes. We created our diffs, and then we could apply the patches on the Linux, and then build it with some changes that we needed. So the customize works similarly, and that enables you to use some third-party manifests or from other team, let's say, and to patch it somehow, and then you can rebase it. So if the resource, the base changes, you can still use it. The customize embraces manifests, so it's built around the objects that are defined within the Kubernetes, and it knows it. So it's different than from the plain diff, because in plain diff you have to create some context, which is usually some lines before the change and some lines after the change, and some the starting line number and the end of the block. But here we are using the JSON or YAML objects, which are objects, so the customize knows that it is a valid Kubernetes resource, and it can use it. The customize is declarative, which is great for GitOps approach, but there are also some commands of customize that allow you to imperatively edit some resources there. The beautiful thing about customize is that it's template free, and so you don't find double braces in customize. And for example, with Helm, when you need to create a totally modifiable resource, you will end up with some kind of skeleton full of empty fields that are to be filled using the Helm values. In customize, you can write your the base, and then you can enrich it again and again on later layers. With customize, when you create your base resource, it should be a valid Kubernetes manifest, so which is nice because you can test each layer if it is valid, and you don't have some kind of intermediate state which is not readable at all. And the disadvantage of customize is that config map key, for example, is the smallest item that you can change. You can't create the configuration tree of the config map using customize. It can't modify such fields. Okay, so that was for the scratch. Now a little dive. So you have to create your customization YAML file. For that you can use the customize binary with the init command, and you can detect your manifest if they are already present in your current directory or another, and you can create the customization file so it will include all the resources that you need. So the customization YAML looks like this kind. There is an API version and kind, and there are some expressions in the YAML that allows you to create or modify the manifests. With namespace, you can change the namespace of all the resources that are to be deployed. With images, you can change the images. With replicas, you can set the replicas of your deployment or stateful sets. And the resources are to include all the manifests that you need. There are also components, and with patches, yes, you can patch the resources that you included. There is a config map generator or secret generator, secret generator, etc. So for the resources, it looks like this. There is a bunch of options how to include your resources in there. You can use a directory with a customization YAML, such base. You can use direct manifests, can also reference a remote, in this case, repository. It could be, I think, whatever HTTP server. And you can use a Git protocol, I mean the SSH or HTTPS. And nice about the Git reference is that you can reference not only master, but you can reference any other Git reference, like tag or even commit. Also, you can include the manifest that, or the directory that is not in the root of the Git repository, but it is on some subpath. So you can just, with the double slash, you can define the subpath and you can build your manifests on it. There are also components which are like resources, but it can be like included from multiple overlays. And okay, I will tell you more. On resources that were included in other like resources, so it's good for writing dry manifests, let's say. Okay, so in Kustomize there are two fundamental concepts, or maybe there are more, but the fundamental are generators and transformers, and they are usually not used directly, but using some expressions as I showed you before, like a config generator or a secret generator. If it's a generator, it means that you create something from scratch, something non-existent, and the transformer just transforms some already existing item or whatever. There is a Helm chart inflator, which is a special kind of generator, and you can write your own generators or transformers if you would like to enrich the Kustomize. The expressions, images, namespace, replicas, patches, etc. are implementations of transformer. The generator and transformer usually are defined within the customization YAML file with their expressions, but it could be directly included using a special expression for generators or transformers. Okay. The most important thing about the Kustomize is patches, because you patch your bases, maybe. So you can target your resources that are to be patched using mostly kind and name, or you can use label selector if you use it in your base resources. It uses ensures regex, which is great because you can patch several resources at once. For example, using a group in your regular expression. The patch itself can be defined inline in the customization YAML file, which is nice because you have like everything in one place, but it can be like can grow very big, so you can also use a file for your patch. So the patch can be in form of JSON patch. It's great for a brief syntax because you don't have to provide a big context, but you use a JSON pointer, which is defined in this RFC. You can find it if you want. And the interesting thing is that it uses a slash as the delimiter for the path in your resource. So if you would like to use a literal slash, you have to encode it as a tilde1. And the tilde is now a special character, so if you would like to write a tilde, you need to encode it as tilde0. The disadvantage of JSON pointer is that you can't address the list item by its value, so you have to use indexes to the index, which is not very great if your base contains some lists and the order changes, you don't know, and the patch can break. So with the JSON pointer, you find what you would like to change, and with the JSON patch, you create or replace or modify how it should look now. There are commands like add, replace, and remove, which can do what it says. And if you would like to, for example, add a new item to the end of lists, you have, for example, some environments in your deployment, and you would like to append, you use dash. Or even if you would like to remove from the end of the list, you can remove. I have to warn you, if you remove your items, keep in mind that the indexes change. So, for example, if you need to remove two items in the list, you like remove the same index twice. Okay, here is an example of JSON patch. You can see there is a regular expression that matches my backend and frontend deployment, and I would like to add disk, some drive for persistent data. Okay, in deployment it's weird, but why not? And so you use your JSON pointer with the path, and I would like to add a new volume called import to the volumes, and then I have to mount it, so I can just add to the container of index 0. At the end of its volume mounts, a new mount called import. And yeah, there is another example of the tilde. I would like to enable forwarding of the proxy ingress controller. So in here, I need to use the tilde1 to write a letter slash which is in the annotation. Okay, that was a JSON patch, and there is another approach which is called strategic merge, which is verbose because you have to provide the context, and the context must be as big as needed, and you have to declare something there, and it is using the how to say, it's in-house like application implementation for Kubernetes. But if the resource is not known to the Kubernetes, it is treated as a JSON merge, which is described in the RFC. About the strategic merge, there is a nice thing that you can delete the whole YAML objects, because in the JSON merge, JSON patch, you can't. But with the special key patch delete, you can delete the whole thing there. So in this example, I don't need the service for Cilium agent, so I just use this special key, and the whole resource vanish. So, for example, if I include it from some base that's contains the service, and I don't need it, I can delete it using the strategic merge. If you would like to use the strategic merge on some custom resource definition, you have to declare the strategy in the API reference. Okay, so yeah, for the strategic merge, the metadata name is required. So, and if you would like to patch like several resources at once, you have to provide some metadata name. So you can write anything there. It is required, but it is not used. There is another thing, how to modify your resources. It's called replacement. And in there, you can address lists by its content, which is great, like in JQ or JMS path, if you know. It's very nice. You can declare multiple targets in a single resource, which is useful. It offers also partial string replacement. So if you declare your delimiter, you can replace just part of, well, let's say, path. The disadvantage is that the source can be defined like literally, but you need to use some resource to take the value from For example, you have to use some annotations, or you can create a config map with your values that you are using as a source for your replacements. Yeah, here's an example of the replacement where I target the subjects list of role binding, and I use its content with name, which is at the devel, and I change the namespace there. Yeah, okay, let's speak something about extras. There is the kubectl diff, which you can use with the manifest itself with -f, but it's also possible to use it with -k, where you provide the directory with the customization file. But when you create your resource in the Kubernetes, it adds some additional fields in the resource, so it can be noisy. So I created this alias, which creates for me the diff that is more readable. You can see that if you would like to use Helm inside Kustomize, you have to enable it like with this argument. There is Kustomize localize, which is a quite recent new command, and as I said, that you can use resources that are remote. You maybe need to localize it to make it like local. So with Kustomize localize, you can resolve the dependencies. You could always use the Kustomize build to get the final manifests, but with Kustomize localize, you will keep your structure of layers for some maybe other modifications. Okay, so there is the Helm chart inflator, and I will speak about it. And the thing is that the Helm chart inflator is not like supported very much in the customized community, and they suggest to use KRM functions. I don't know if you heard about it. It's like it should be built directly in the Kubernetes, and it's a way how to enhance the tooling. It works like a little containers where you put some standard input with your manifest and some specification what should happen inside the functions, and on standard output it will build some final manifests that are to be deployed. Okay, so the Helm chart inflator, as I said at the beginning, you can use your generator with the shortcuts in your customization YAML, but this approach is buggy in Kustomize. There is a GitHub issue opened several years, but with the generators approach, where you defined your file with the generator in your customization YAML, and then you can create a manifest of kind Helm chart inflation generator. That way it works. You have to enable it using this enable Helm argument, otherwise the Kustomize will just pop some error message that it is not enabled. There is another feature or issue, I don't know, there is some discussion under this link that if you create if you use the Helm chart in Kustomize and you build your manifests there, it will create a directory for the charts in your current directory. And if you, for example, change the version of your Helm chart, it is not pulled if already present. So you have to delete the directory yourself. Okay, and great thing about the Helm chart inflator is that you can use the Helm, generate the manifest, and you say, okay, the Helm is not so versatile as I wish. I would like to, I don't know, add some volume there, add some limits there, or maybe, I don't know, some affinity, whatever. So I can use it as a base layer for some other customized layers, and I can modify it. Yeah, okay, so, and the last slide is like from the wild. As I said, that you can use remote resources, and remote resources can use a Git reference. You can end up with something like this. Because we are a project company, we create a project with of like different applications. But for deployment, it's similar. So we use similar base layers for different projects, and in each project have several environments, and each environment use like different bases. Yeah, maybe I will open it using this. So, for example, in project 1, I have some production environment in which I defined that the image should be this, and I need, for example, 3 replicas of the application, and it uses application 1 and application 3, and the development environment of this project uses also the application 1, but the application 3 is on different tag. So there has been some change in the customization of application 3, and you are not ready to deploy it on production yet. So, but you can deploy it on dev. And for example, in here, I have some common customization for some infrastructure application, and here you can see that the production uses some old tags, but the dev and test is on different tags. And at the end, it can look quite difficult to read. Okay. So that's all from me. Thank you for your attention, and you can have some questions.
Thank you. Thank you for presentation. I have only one question, and I think I'm not one eager to know. Why did you choose customized over Helm?
Because I don't like double braces. I know. It's because that with customize you can create small iterations that you can build your like the manifests, like plain manifests, and when you are like quite okay with it in your like proof of concept, you can use it, and then or you can enhance it. And as I said, we are a project company, so we build a lot of different applications which differs a lot. And with Helm, if I would like to make some change, I have to go to the Helm, to the template, to change it there, and then I have to apply it for all my projects. But with Customize, I can just apply a tiny patch over the base that is common for all the projects that I use.
To bublalo do streamu. Prskalo. Ty čajk?
To je čajík, no. Jak dneska nemůžu chlastat, tak jsem si vzal čajík. Tak, kam to připnu? Takhle? Bude to takhle fungovat? Test. Raz, dva, tři. Raz. Raz, dva. Raz, dva. Huh. That doesn't look right. So. Okay. Yep, it is. Just a moment. Okay. Yeah. So, nothing yet. Oh. Please work. It's not doing anything. Come on. Yeah.
Tak se ti nepomůžu. Chceš, když tak nepočítáš?
No, já to nemůžu, takže vydrž.
Tak za něj může počítat.
Hele, no to rebooty. Okay, so 2-minute pause. Sorry. Jak mi nešel nabootovat, přehodit display, output. Tak moment. Okay. Linux. Xcode. Jo, vydrž, jenom mi to nechce nabootovat. So, just a second. Okay. Možná, ale já nemám prezentaci. Okay, so this is a sad story. So my laptop died yesterday. So this is the backup laptop, and so I did reinstall yesterday. But this laptop might have a bad memory bank at some point, and it has issues with like booting, and sometimes when you allocate a lot of memory, it just dies. So hey, success. Let's hope for the win. And we will wing it from there. Okay, output HDMI, please. Go for it. Nothing? Something? Oh, awesome. So I'll just like change the resolution and everything will be just fine. Okay, that's a success. So let's hope nothing actually dies. Yep. Okay, is this better? Okay, awesome. So, and this is better, right? So this is readable. So, okay, let's begin. Apologies for the rough start. It's definitely gonna get much better after that. You see how professional I am. Anyway, so let's begin. So this is not a trick question. So what's that? Like, just shout. Like, it's very small. Can we make it bigger? Better. So since you can see it, you will probably know what it is, right? Just shout, like dump answers only. Yes, it's JSON object, right? Yes, so it's a JSON file technically. So this is a tricky question. What's this? And yes, this is a trick question. Wrong answer only. So yeah, this is a YAML file technically. Like, wait, what? Yeah, so it turns out the YAML JSON is actually a valid YAML. There is a link to the reference for fun. No useful information there, but technically you can just use JSON wherever YAML is valid because the parsers all actually accept it as a YAML. So this is another tricky question. So what's this? It's technically correct, but no. So this is a JSONet. Yay, surprise. So JSON is actually a valid JSONet. So hi, everybody. I'm Philip. I'm assistant engineer at Microsoft. I currently work there at internal runtime platform. Mandatory disclaimer, I'm going to talk about stuff here, and those are only my opinion, definitely not that of my employer. Quite likely not opinions of that your employers. You will need to push those opinions on your employers yourself, unfortunately. So agenda. So what are we going to talk about today? And JSONet and Tanka, and roughly in that order. Originally, I wanted to make this a lot more about Tanka and a lot less about JSONet, but then I realized that Tanka is mostly just pretty wrapper about JSONet, and JSON is the thing that actually doing the heavy lifting there. So it will be a lot of JSONet and a bit less Tanka than I hoped for. So the talk should have a maybe different name. But that's how life is. And my poor planning did a lot of that too. Anyway, I expect that you know a bit about Kubernetes and Helm. Actually, some decent amount. So if you do struggle, hey, actually, now it's parsable. So this is a link to the Git repo. You can scan it. It will be on GitHub. It's empty now, but there will be stuff there. So anybody can scan it. Okay, cool. Anyway, so what would I like to do on this talk? So the goal for is like what you're not getting out of this talk. You will definitely not be JSONet or Tanka guru. No way. But you might become one. It's small again. Okay, bigger again. Huh. You've seen my you've seen my preparedness, right? Might be. Anyway, you will not be a JSON on tongue category. By the way, just shout your question. I will try to answer them as we go. No need to really raise your hands. I'm not all that into that. Anyway, but what you will get out of this talk? So hopefully you will understand whether JSON and Tanka has something to offer you. That's the very big thing. If you decide that it's for you, that there are some links to the great JSON and Tanka learning resources, and some projects that actually use those, so you can use that as a reference. And hopefully a realization that your relationship with Helm shows signs of Stockholm syndrome, because I do not like Helm. So what's wrong with Helm on that topic? So there is a bit of that, but let me get a bit into Helm, why I actually don't like it. So it's strength templating for structured data. So yeah, for whatever reason, somebody decided to use Go text template for a white space significant data format. So yes, ident 8, if you haven't written that at least 600 times while working with Kubernetes, you haven't seen enough Helm yet. And I think your appreciation for JSON might not be quite there. Also template. So do you know what it is? It actually renders a string in Helm as a template. So you can template value template by your template in your template. Awesome. If you haven't spent like three hours debugging one of those, you need to try it to appreciate JSON a little bit. So somehow Helm is like a tool which is bad at producing valid YAML. Yep. And I'm like throwing a lot of shit at Helm, but Kubernetes, when Helm started, Kubernetes were a lot less complicated. Also, it wasn't the de facto standard, so it was the simplest thing that actually worked. And we need to give credit to Helm for what it's worth. We are basically building on the shoulders of the giants. Because we probably wouldn't have the Kubernetes we have today without Helm, or something similar to Helm, but Helm made it a lot more successful than it would be otherwise, I think. And here comes the realization of last few years that Kubernetes API objects can be actually treated as structured data, because that's what they are. And that's where the new emerging class of languages actually comes from. And those languages are specialized for configuration data generation. Emphasis on the configuration data, actually. Not just any data, you can generate any data, but it's more practical for actually configuration, like complex configuration, intervened dependent data, which Kubernetes happens to be a case like that, with all the API resources there being all configuration technically. So there are like examples of the languages. JSONet, that's what we are going to talk. Q and all of these three actually comes from ex-Google employees. I guess that they had something fancy inside, and they were desperate to find Helm out when they left Google. And now there is also Pickle, which is from Apple. Actually, they released that like 2 months ago. So it's a new thing, new kid on the block. It's cool, everybody likes it. It's slight improvement over Pickle, over JSONet, but sure. But ultimately, the JSONet is the most widely used out of these slightly exotic languages for Kubernetes. So the most support you will find with JSONet. So what is JSONet? And this is a bit scary slide. So JSONet is purely functional, lazy evaluated, structured data generation language. So that's a lot of like scary words, right? So don't worry, I have a bunch of examples that I will demonstrate those words on. Okay. And like point out which part it is. And by its nature, it's extremely flexible language for this use case. It lends itself exceptionally well to generating Kubernetes API resources and manifests. So yeah, JSON language overview, 3 minute, 5 minute dive. Okay, Let me find the examples. Yes, so this is a valid JSONet. Again, sorry, this is valid JSONet then. Readable. So every JSONet program starts with like top level is an expression that actually returns value, and that value needs to be possible to convert to a valid JSON. So 21 plus 21, and you can see, is that readable? God damn it. It's 42. Awesome, but it's a valid JSON actually, and this is a valid JSON program. So when I said functional language, it means it's a top-level expression that can be composed of possibly more recursive expressions, but ultimately the whole thing is in its pure form, pure function. So there are no side effects, and this is maybe, I have an asterisk here. It's not always true, but mostly yes. And yep, that's example number 1. Example number 2. So again, small, sorry. Yes, so this is a JSON, and if you evaluate it by JSON, it's also a valid JSON. So JSON in, JSON out kind of makes sense. This is how would JSONet that's not JSON look like. So you can see that the keys here actually missing apostrophes around it, quotation marks. So it has a bit better syntax than plain JSON. So some life improvements actually. And okay, this is not going to be readable for you, right? Okay, let me close this. So this is still small. This is bigger. Okay, basic example. So this is more of a comprehensive example of JSONet. So it has like commands. Wow, in JSON. Wow, commands. Anybody? Nobody? It has local variables, lexically scoped, top level expression, and that can be only one in program, and recursive expression. So you have your typical JSON scalar values, arrays, dictionaries, or objects. You can reference yourself to the local variables. You can reference yourself to a lot of things. Here is one of the more powerful features. If you do double colon, I guess, it means that field is hidden from the output. So when you evaluate to the top level expression, top level value, that then gets converted to JSON. This basically says, hey, I'm hidden field. Do not include me in the output. So you can hide like your helper variables or helper functions or whatever you need. And the only form of conditions are actually ternary operators. So those are actually expressions too. So it's expressions all the way down. And if you evaluate this, again, small, awesome. Okay, planning, how do I make this bigger? Yep, it's just JSON. You can see that the hidden field actually is not there, included as expected. Not sure if anything else needs to be said. Oh yeah. Okay, whatever. When I actually do this thing, I actually calling some like a JSONet binary that actually takes the file, converts it to the output, and this is actually the output. Anyway, more examples. This is number 4. No. Oh, maybe. Like technically, JSON doesn't have any guarantees on the lexicon. Yeah, but like you mean like this is sorted. The output is not. Yeah, but it's implementation dependent. You cannot rely on being the keys sorted technically. Yeah, it's just implementation detail. I wouldn't rely on that. If you need something sorted, then sort it, especially on the object level. Okay, number 5, actually more powerful features. So imports. JSON can actually do work in modules. It's actual language, and the import is actually one of the best I've seen. So the import path is always relative to the file. And you can actually import like libsonet is by convention. You can call those JSONet files. So you are importing other JSONet files, and then you can actually access the fields nested there, even the hidden ones. But you can also import just JSON files or even YAML ones if you seriously need to do that. And this is like what we are importing. So again, if I do that, you see like just string concatenation and accessing the fields from the important object. And okay, sorry, number 6. Now this is one of the like actually better features why we are here. There is a notion of like merging in JSONet. It's similar to patches in Customize. It's a bit more powerful. So you can define. So here's like object A. Here's some object B, and you basically like this thing. Actually, this plus over here actually defines how the merging is going to happen. So when you combine this object and this object on the metadata field, and you are overriding, we want to change this namespace, right? So we are basically going to end up with overridden. But if you wouldn't have the plus here, you would override the whole object, so the name would disappear. So let me show you the example. Okay, this is readable, right? So the name is included. If I actually do this, it overrides the whole object. So you can control very specifically at which place you want to actually do the logic of combining the values, and in which case you want to override the whole value. Oh yeah, and list. So how does the plus works on list? Not that beautiful. Depends. If you don't include the plus, it does the override as with object. If you include the plus, it's actually concatenation. So yeah, like lists in JSONet are a bit annoying to deal with. It's one of the weaker points. But you can generate lists. That's what you would be doing most of the time in Kubernetes. Okay. Functions, you can define your helper functions. Those are all just expressions. You can also define methods, let's call them, on objects. So this would just be like calling, hey, self dot, and self always references the current object on the like closest level object. So it would call this greet method with argument. Yeah, you probably want to hide those functions, or at least not get them into the output, because you cannot render a function. It doesn't have like to a JSON. You cannot have a representation of a function, or at least in JSONet in JSON. So the path where you actually render the like resulting data structure cannot have. Oh, you don't. Let me show you. Yeah, you get the runtime error. Couldn't manifest function in JSON output. So it will tell you, and it will tell you where this happened. So. And I guess this is last example. And this is the like second or third like major feature. So when I mentioned the lazy evaluation, what does it actually mean? Like the lazy evaluated function. And it's like very powerful feature, but it's like one of the hard parts of JSON to wrap your head around. So you have your lazy object, and then you merge in another object. And that merge actually overrides one of the fields in the original object. So you basically update the value. But in the original object, you have a self-reference to this one that you are actually overriding. So JSONet is actually lazy evaluated in that it waits as long as it can to actually manifest the value, or manifest is probably not realize the value. So if we actually execute it, you see, let me make it bigger, maybe scroll, yeah, that all of those actually got rendered into bar, 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 which is something we actually did in the merging. So it should have been foo if it wouldn't be lazy evaluated, but you've updated that to bar, and only after that you just forced the evaluation to our actual value. That's JSON. JSON is the actual value in this case. So you can actually like define your Kubernetes objects with some logic inside them, and it says, hey, these are like 6 fields over here. If you change them, we will use them to generate all the complicated logic outside. You just basically make it like you can introspect the object, make changes, and still have the whole logic contained. It's a common pattern in JSONet. And last thing I haven't mentioned, and this is like probably the one that's actually super powerful. You can actually, when you are doing the plus, the merging operation or the inheritance, that's how the official documentation actually calls it. This super dot something actually refers to the object that you are merging on the left. So the super dot bar is actually this one, the one from lazy evaluated stuff. So you can actually access that. Super useful if you want to, for example, in Kubernetes, like steal a selector for pods or something. So when you are doing, for example, pod disruption budget that you kind of want to generate for something already, you can just like take a look at what that is and just, hey, whatever the selector is, just use it and for the pod disruption budget. It should work. Yes, that's the whole point of hiding. So sometimes you don't want to show the values in the output, but you want to, for example, offer that as a part of a library or some logic that you can basically embed into your library. So that was the 5-minute-ish examples, and yeah. There is actually 5-minute overview. You can go to this link. It's better than what I've done here, I think. It's actually text structure. Somebody actually thought about it. So this is another example. So JSONet is a Go library. So you can use it as a Go library. And you can do stuff like you can embed JSONet in your own tools. So you have like very powerful configuration engine in your tool, or you can actually inject your values from Go into the language runtime, which is precisely the moment where I say you can actually turn purely functional language into not purely functional language, because you can inject functions that are not without side effects. Let me, come on. Yep, so let's go for this one. Is this the embedding one? Yeah. So, and it's actually super simple. So bigger? Thanks. Whoever says bigger in the back I owe you a beer. Thank you. Actually appreciate it. So this is how actually the embedding looks like. So you just take the library, create a VM, and then just like point it at the file, and it will evaluate stuff for you. That's it. And you can actually do native functions, which are mildly more complicated, where you actually need to do the same stuff with the embedding, but also say, here's a native function, which is just a structure in Go that points to a function that is basically this interface. So in this case, I'm just violating the purely functional no side effects thing, and I'm just generating random values. because why the hell not? It's not, random values are not in standard library. I can do that. This not actually started working. I think I will need it to start working. Yep. I did something wrong. So when they actually tell you to not do live demos on presentation, this is like what you're not supposed to be doing. Okay, for whatever reason, I need internet connection, so let me fix that very quickly. And we can get like back to how this actually works, but if you take my word for it that this actually generates, and this is the part of JSON that actually works, calls the native functions. So the result here would be another beer. Okay, I'm going to be handing over a lot of beers today. Anyway, it's just std native, and whatever you registered as your function, so this would get registered as two random values, floating points, actually. So this actually lets you do some wild stuff, very flexible, like taking Helm Go library and actually just embedding that into your Go program or customize, or basically anything you want. And I think this is the time for, links for great resources. This is the grand reveal for Tanka, because that's what Tanka actually does precisely. It registers a bunch of native functions and does some guardrails for you. So JSON is widely flexible, and you might not want to always do that. So it gives you some guardrails. Yeah, one step back, learning resources. I recommend there are two great tutorials. At some point, you will probably end up at language reference. There are some stuff that's not in the tutorials you might see in the wild. And I recommend highly, when you actually decide whether JSON is something you want, to take a look at Kubernetes, which is one of the biggest open source projects, like actually brutally massive projects, actually utilizing JSON. They even use it to generate the Helm chart most of you are probably using. So for those who do not know, Kubernetes is a monitoring in a box kind of solution for Kubernetes. And if you do it, like use it fully, it's something like 70,000 lines of YAML stuff. So you need a lot of flexibility to manage that complexity, and they do that by using JSON. Anyway, Tanka. So Tanka is Grafana Labs open source project. It's not particularly famous one. Tanka is pretty great tool, but it's just an example. I'm using it here as a mostly example of what JSON is actually capable of, and what you can actually achieve with it. But it's completely fine to use it alone. I at least know about at least one company that's using it in production. So it wraps the JSON in nice Kubernetes API resource generation, and it's a deployment tool too. So it's just not generate like data generation. It's actually can deploy stuff with too. And you can think of Tanka as a Helm, but with JSON instead of the text rendering, text template rendering. So you basically take Helm, rip out the text rendering engine, and just plug in JSON, and you have basically Tanka with some mildly different decisions being done. So yeah, Tanka is actually nice because it gives you some guardrails. It gives you like how to set up your project around JSON. It's probably best way to start with JSON and Kubernetes, and that's why I'm showing it here today. And yeah, so it does show you like Terraform apply style JSON. It's actually super nice, and if my terminal will start working, hey, it started, then I will actually be able to even show that div. Because, yes, another example. But given my laptop got kind of killed, we might not be as happy. Okay, maybe. Okay, so. Yeah, I know, but what you're basically missing in me is me actually trying to start a JSON. Okay, so okay, it's running. I'm shocked. Maybe not that running actually. Anyway, so Tanka. Tanka gives you a command that's called TK. It gives you a lot of nice features. It has like initialize my empty directory, which will just basically create a directory structure like this one. It will populate for you some basic libraries that you might want to use or might not want to use. And it has a similar approach to change management as Terraform. So basically, Tanka apply will reconcile the state in Kubernetes to the state of basically your Git repository, hopefully Git repository. What the hell is going on? It has some nice stuff around it, but you are mostly like I will be mostly showing the show and apply. So the directories are not all that important for the demo. You can read that in documentation if I catch your attention. Let me fidget spinner. Let's go. Is this readable? So basically, JSON stuff got turned into an API manifest. Simple namespace deployment. How does that actually look like in JSONet? So let's start from the mildly smarter approach. Is JSONet Tanka actually wants you to use a certain directory structure. How you structure the environments is up to you. It might depend on what environments your company actually has or what you define. So dev, production, regions, namespaces, whatever. It will let you do all of that. But it will force you to use some libraries or library like paths. It will auto inject those for you and other interesting things. No, I don't think so. At least there are like 3 different modes that you can run Tanka in. I think in one of those it actually manages the namespace fully, so the whole life cycle of the namespace. In one of the modes, you can actually define like how many namespaces you want in JSONet. You basically produce a namespace-like object. And in one of those, you just manage a subset of what's in the namespace. And the one where you don't manage the whole namespace is the default one, I think. So this is also an example of like one of the libraries that are in JSONet that actually helps you generate Kubernetes objects. I know it's not beautiful, but this is like basically these 4 lines that like define, like created the whole thing I've shown you before. So if you do decide to do something in-house fully in JSONet, this is probably the recommended way to do it, but nothing really stops you from just writing YAML and then importing it, and then do some manipulation on that, merging and stuff like that. So the whole flexibility of JSONet, you can do that. And yeah, so basically what this does is create a new container, creates a namespace and a deployment. That's all of those are functions from the library. So can show you what that actually looks like if the cluster's working, and it's working, and it's too big. But okay, so this is where I compared it to Terraform. So you say Tanka apply and the environment, and if it will show you a diff. It's beautiful. Oh, come on. It's green. Okay, look at that TV. It's visible over there. punk, I know. Okay. I don't think I have a Teams here, so I cannot really change it. Okay, anyway, it creates those two. It asks you, yes, I want to apply this to the server, and it got created. Trust me, I will show you that in a moment. But for example, you now decide to change, I don't know, the memory of the bot, and you do that again, and yeah, you have actual diffs for your changes. So if you are like generating 10,000 lines of YAML, Helm doesn't really show you that, what changed compared to the running cluster. This tool actually does. So in that sense, it's similar to Terraform. It's nice. What's not so nice about it, it's not an actual Terraform style plan, so you cannot save it and reuse it later. It's just just in time change. You can actually validate that this is going to your clusters. So on larger scales, this is probably not what you want, but for development, super awesome and useful. Also, when you have a bunch of developers seeing Kubernetes for the first time, actually seeing the changes makes them iterate super quickly. Okay, so yeah, what I didn't mention here is that Tankard is also different in other ways from Terraform, if you've ever seen that, is that if you remove resource, it will say, yes, I have no changes for you. The apply doesn't really remove resources. There is a, is it prune? Sorry. Yeah. Sorry. It's prune. Okay. And now it's like notices, hey, there is a resources. It like notices the resources by label that it auto injects. So it will just iterate all of the resources in the namespace, and it just finds those that are not in the current desired state. Less ideal than Terraform in this sense, but it works. And yep. So that's the orphaned resources. And now comes the hopefully the selling point. Yeah, I still have time for that. Awesome. So I have mentioned introspections and mixins. That's the actual powerful feature of JSONet. So you can like introspect a deployment and just say, hey, I want PDB, pod disruption budget for that. And just like take a look at the deployment and generate something for me. It can do that. I will show you in a minute. You can do that for HPAs and inject your default values, that whatever you think, and you think mean whoever wrote that function or that transformation is good default. Depending on who you are, that might be a killer feature or just meh kind of thing, but most of you will probably find that actually useful. Services, you can actually just generate a whole lot of objects from basically a single deployment. And you can generate most of the deployment from using JSONet anyway. And I will show you the Helm integration, because that's also a great thing. So let me jump to the example number 2. This is readable? More readable? Less readable? Okay. So similar thing. And this is the Helm example. You can actually just render Helm and just apply that to the cluster. So what this does is actually it takes a Helm that's bendored in your Git repository, takes the Go text/template kind of library, supplies the values to text rendering, and just renders the Helm chart into a realization of the values. So what you get is just like, and then goes and parses that YAML and basically returns JSONet representation of the data structure. So this thing now contains the whole parsed data structure of the Helm chart that would represent. There are some naming convention, but basically here is how would a deployment look like named fidget spinner. So we can reference that. And then you can, for example, do the introspection. There's a lot of happening here, right? So I will show the Helm maybe first. Here. So like uber simplistic, awful Helm chart I've written in car on my way here. Yep. So just creates a deployment, has some values and stuff, and why in the God's name might you want to actually do this in your entire life, right? So there are times with Helm charts that they basically do the thing you want mostly, but you want to add, I don't know, it doesn't expose for disruption budgets, or God forsake, you want to specify topology spread constraints that have actually some like correct label selectors there. In Helm, that's like super difficult. You cannot really do introspections. You need to resort to template in a template in a template usually, maybe some defines. You can do just the inspection here. So what you can do is render the Helm chart, supply the values that the Helm chart actually supports, and instead of like asking the upstream of the Helm chart, because it's most likely upstream project, to add your feature, you can just patch it yourself. Just use JSON to patch your stuff on top of it without actually changing the upstream. Yes, you still want to do the upstream. Like, it's open source project. If it's something they would be interested in, please contribute. But sometimes you want to add your crazy CRD that they just decided not to support because they had like 20 different projects with custom resource definitions in Kubernetes, and all of them want to have a place in all of the Helm charts, and they must be able to say no to some of those. So if you want to do the introspection and add your feature, you can just render the Helm chart, supply your values in JSONet, and then do the JSONet part. And this is the introspection part. So you can actually take a look, and this is basically a function, call it. And it's not that important like how this works, but you can just define your function that accepts the deployment or any kind of controller or replica controller in Kubernetes, and just do the inspection. So I want pod disruption budget for this Helm chart that I don't want to modify, and I don't want to, the important part I forgot to mention is I don't want to fork that Helm chart. I don't want to create our own copy of the repository, apply our changes, and then like maintain it for the rest of our lives. Because if you do that 20 times, which is basically what you do with Kubernetes these days, you have like 20 different Helm charts you need to apply before it's actually fully fledged Kubernetes. You have like 1 or 2 full-time engineers doing nothing, just maintaining the Helm charts, applying the changes on top of the Helm charts, and that's a wasted resources. So you can actually take the Helm chart, unmodify it, render it, and then do the structural editing on top with JSONet, which is significantly more resilient and robust than actually maintaining like a Git patch on top, like string-based or diff-based changes. The structural editing is significantly more robust to basically random white space changes. And what this does is just basically takes a look at the metadata in the deployment and creates a PDB with the same labels and label selector. It just copies over, hey, the deployment has this spec selector. I just want to use the same thing because I want to select the same pod as the deployment's creating. So I can just steal that and just generate my object for that. Let me show how that actually looks like, because that's probably hard to imagine. Yeah.
For the deployment, you generate it using the Helm function. Can you do a kind of filter or mapping or something like that?
What do you mean?
For example, in here, you are modifying just a single deployment. If you would like to modify more.
All of them. Yeah, like JSONet has a for loop. So you can just like loop over all of them. It has like, it's functional language.
The object seems like deployment underscore widget, whatever.
Oh, right. So you can like actually loop over this thing. So this would contain all the top level objects in the Helm chart. And this like deployment fidget spinner, you would have to like, it's a bit annoying because it's an array, sorry, not array, object, but you will be iterating over all the top level objects that the Helm defines, so all the services, HPAs. And not necessarily, you can just like iterate and say if the object has kind double dot deployment, then do your changes, or any of the deployment replica set, stateful set, the daemon set, whatever. So you can do a for loop with if in it. So it's like generator for loop. I haven't shown it yet. Like I haven't shown a lot of the language features here, to be honest, because it's complicated language. But you can do like automated changes, and you can do this on massive scale. JSON is like the Go implementation. It is super fast. So I remember generating something like 70K of YAML lines, and it took like a few seconds. But if you iterate a lot, it can be a bit expensive. So having everything as an object where you can reference by field is usually more effective because you are not iterating over all the objects several times. So what this does, actually here is what is generated, and eyes on the TV again. Sorry about that. But this is the pod disruption budget that got generated from the deployment. So it actually stole this part, and it stole actually the metadata, because why would I actually fill out the metadata that I just can copy over and just not write them all over again? I want the metadata actually uniform across the whole kind of bundle of objects that's specific for the workload there, right? And the result is that the metadata got kind of stolen over. You can still do some modification if you want to include more labels, or you can use a different name or something. And the label selector actually got stolen over, right? So this thing actually got introspected and, and copied over. And you can do that like 6 different times for the 6 different objects. And all your developers need to do actually at that point is define a deployment. Sometimes not even that. And you can generate for them like horizontal pod autoscale, pod disruption budgets, services, ingresses, a whole lot of other things that I don't remember out of my head. You can set default values for a lot of things. Like sometimes you are running weird Kubernetes setups. You can do like external secrets, external DNS. That's also a thing I remember. Pod monitors or service monitors. That's a CRD from the Prometheus operator. You can generate all of that from single point, and you can have that uniformly across a whole lot of workloads in your company. So this is the last slide, I believe. Maybe, I think. So what can JSON do for you? So let's start with like personas, basically. So a developer writing their own manifest for a single service. That was kind of scary, right? Like it's not that simple. It's kind of a large investment. It's really flexible. It does let you do a lot of things. But if you are doing all of that work for a single service, then you are probably better off with just plain YAML manifests or Helm charts, because that's intuitive, simpler, and you don't need to learn weird function language. On the other hand, my major selling point here is just probably Tanka diff, Tanka apply. You get to iterate quite quickly. So if you are a Kubernetes admin and you are like basically setting up the Kubernetes, all the operators are the CRDs, all the stuff, and you want to have the uniformity there, it's awesome. You can like set up and override labels on everything. You can make uniform names for everything. You can uniformly set up resource requests, limits, topology spread constraints, stuff like that. You can also like have a single tool, a Tanka, that actually can do like plain YAMLs, JSONs that got somewhere generated. You can do Helm charts. There's even like experimental support for customize. So all the major stuff that's there, you can use it, and you can have that in the single tool. It's actually flexible, but it's still a lot of complexity. Also, Kubernetes is awesome, and the Helm chart is simplistic version of that. So if you want to use full power of Kubernetes, it's written in JSONet. you want to use JSONet for like getting the most of it, because not all the features Kubernetes can do for you are in the Helm charts, because it would be unreadable, unmaintainable, kind of mess. And lastly, a platform team. So this is where you are basically setting up Kubernetes for your whole engineering organization that deploys stuff to Kubernetes. And this is where like JSONet and to a degree Tanka really, really shines. Because you can do stuff like just library for everybody. That's like everybody's using that single like you can expose the Kubernetes to the developers, setting up the same default values for them without them ever knowing anything about pod disruption budgets. You can just do the, hey, give me a deployment and we will do the rest for you. And if there is a like team that wants to be, thinks they are know better than you, they still have the flexibility of, hey, you generated a lot of stuff for us, and we think that this kind of pod disruption budget you are generating for us is not what we want, and they can still override that. So the flexibility here is you can set same defaults, but the teams, if they think they know better than you, they can override those defaults, and they have the flexibility to do that. So you can do the like embedding the best practices and same defaults. So if you've ever read Netflix blog or read anything about platform engineering, this is called the paved road or golden path. Yeah, and sometimes Tanka might not be super like enough for what you want to do with JSONet. With Tanka, and you might actually want to start actually building your own tool. So the Go library is super simple. I've shown you an example. And you can actually do stuff like generate pieces of Terraform from JSONet, like the glue code. It's flexible. You don't need to recompile. It can be like still readable and still like generate like all the different clusters and environments. I've actually done bits of like Terraform code generations from JSONet. It's not that horrible. It's not nice, but it's possible. And you can like define your platform manifest for the whole engineering organization, or at least the parts of the engineering organizations that care to listen to you. And basically generate from single file, single source of through all different pieces of configuration. So for example, it doesn't have to be just Kubernetes, right? Not everything needs to go through Kubernetes. Sometimes you need to set up an external load balancer that doesn't have integration with Kubernetes. Or, I don't know, DNS steering or regions. Like, imagine you have like 63 different regions that you want to deploy to. And you want to have some failover, like complicated failover logic that's not in Kubernetes, because Kubernetes are regional only. You want to be above, like, you want to orchestrate across Kubernetes clusters. So that's kind of difficult to do in Kubernetes. And with Kubernetes native approaches, there are starting to be tools available to do that. But JSONet is one of the approaches you can take. Basically, generate everything from the single source of truth and take the pieces of configuration you've generated and send them to the respective systems and reconcile on them. And that's the end of talk. Yeah. This is bonus slide. Anybody? Do we have still like a minute? I should, okay. So JSON is not like all great and awesome. I hope that I haven't like made this slide pointless and everybody in this room thinks JSON is awful. I don't want to ever see it again. But it's not like all powerful. It's the most used one. It's the like of the all languages I've shown you. It's the most. Nobody said bigger. Anyway, but it has some not nice things to it. It's the most used one. It has the biggest Kubernetes libraries for it. There are multiple tools apart from Tanka, actually, but Tanka is the nicest one of them all, as far as I can tell. So the language itself, so sometimes you are not sure when you force the lazy evaluation, and that can happen in the middle of the evaluation. So you think you have a like JSONet object that isn't evaluated to actually realized value, but that happens sometimes in the middle of the evaluation. And JSONet is not very good at communicating when that happens. JSON is not really suitable for data and schema validation. So some of the other languages can actually do that for you, and they are very good at that. DOL or QLink can do that for you. In JSON, it is a bit cumbersome to define basically schema and validation. You can do that in other languages and then plug in JSON, but why would you do that? JSON is, compared to other languages, it's super flexible. It lets you do weird and wild stuff, and you might actually think before you actually do something. It's like C. It just lets you. As asked, this is one of the pain points. Modifying arrays, it's kind of not always fast, and it's a bit weird. Some languages do handle it better. And the syntax, like I know curly braces, JSON-like, not super compact as a YAML, but it's doable. So pickle is something that's been talked about lately. It's the thing from Apple. Fixes a lot of the pain points from JSON, actually all of them. But it's a new kid on the block. It will not be ready for a few years. So I think it's still super safe to actually use JSON for next 5 years. Definitely, probably a decade even. JSON's just a language. It's just a language runtime. If it goes spoofs and nobody develops it anymore, it will keep working as it does for the next few decades, really. So it's relatively safe bet, but if you use some tool on top of that, like the Tanka, you might actually think about the support from the maintainers. And that's the end of the talk, I think. Yep. So apologies for my unpreparedness and not so much professionality. And I'm happy to answer any questions you have. Okay.
Not a question, but a comment that Augur CD supports JSON natively, and Tanka can be used as well.
Oh, so they got our support. Awesome. So apparently, it's not mainstream, but there are definitely companies that use it. I know at least about 3 of those, because I've worked in some of them. And at least one I actually introduced JSON. So the groups are sitting over there, those are Shumax people. They don't, you can ask them how well that went, if they like JSON or not. I might be a bit biased. Because after the horrors I've seen in Helm, and back then Kubernetes Customize wasn't all that ready, it missed a lot of features that apparently it got fixed, a lot of them. JSON was like godsend in flexibility and how it can actually do stuff compared to Helm. So that's it. Oh. Okay, can I do a rollback? That's a tough question. I think this thing goes only forward. Oh, okay, sorry, rollback. As in not on slides, but on with the Tanka. Yeah, so technically you can check out like older versions. So the philosophy of Tanka and JSON is what's in Git or source control should be what you get and should be represented. Like it should be the input and sole input to the what gets applied to the clusters. So there are no side channels that could inject some values to that. So everything should be in Git. If you check out to a Git, you get the exact version of what should be in your clusters. So that's how you would do a rollback. But given how security people are, security patching, stuff like that, it's usually only a roll forward for you anyway. You cannot just go half a year back and just apply an image that was used back then. You need to apply a new image that has all the security patches in it, right? So it's mostly roll forward for you, or at least make a feature branch, update the images there, and just update. If you do need to roll back like a few hours of previous year release, yes, it's just like Tanka apply and Tanka prune sometimes, because it doesn't clean up all the resources automatically. That's the not so beautiful part. And in Shumax, that was basically what we've done: Tanka apply, Tanka prune, when actually deploying and rolling back.
See what wasn't pruned, we had a job that ran once a day, and it like create an alert in alert manager to tell us there is like inconsistent states with Git. That was also pretty cool.
Yep. So thank you.
Thanks. Hey guys, please don't leave. We have some